Hey students, this is lesson 3.5, working with sets. You will learn to write sets and identify subsets, and you will learn to find the complement of a set. All right, here's the review. Cross out numbers below that are not whole numbers. That would be 2/3 and 6.3. Describe the relationship between the set of whole numbers and the set of real numbers. Whole numbers are a subset or part of real numbers. All right. And there's some important definitions in the vocab builder. A complement of a set is a set of all objects or elements not in the set. And then we have some new symbols we're going to use, and you'll see how those work soon. So, complete each set with another element. Eyes, ears, nose, mouth, maybe. Mother, father, brother, sister. Seems to fit. A, E, I, O, U. Suppose that the universal set of coins is penny, nickel, dime, quarter. Let D be the set penny, quarter. What is the complement of D? Notice the notation. D with a little mark there like that. That's called D prime. Or the complement of D is those elements not in D but in the universal set. So the ones we're missing are nickel and dime. And that's the complement of D. All right. I'd like to point out a lot of good information. I hope this is in your notes. And it is the roster form, the set builder notation, important information for you to know. Here's some examples of roster form, and basically roster is just using braces to include all the elements of the set, and set builder is a little more descriptive, describes what's in the set. I'll show you some examples of both of those. Here we're going to write M is the set of whole numbers that are less than 5. Whole numbers less than 5 include 1, 0, 1, 2, 3, and 4. In roster form, we just list those, so we say M is equal to brace 0, 1, 2, 3, 4. In set builder notation, we say M is equal to brace, and we use X to represent all the members of the set. And we say X, this line is read such that X is a whole number. Comma, and that's read and X is less than 5. Let me finish that with a brace. So that's set builder notation. We'll do some examples here. We want N is a set of even numbers that are less than or equal to 12. How do you write N in roster form and set builder notation? Let's make sure we have all the numbers that we need. All even natural numbers that are less than or equal to 12. That would be 2, 4, 6, 8, 10, and 12. So in roster, we just list them using brackets. So we have 2, 4, 6, 8, 10, and 12. In set builder, we describe them in this form. N equals all X such that X is a natural number, and that comma there means and X is less than 12. In set builder notation, how do you write the solutions of negative 4x plus 3 is less than 15? Let's get the solution first. Using the subtraction property of inequalities, I get negative 4x is less than 12. Using the division property of inequalities, I get x is greater than, we had to reverse the sign there, negative 3. So in our set, we want all numbers that are greater than negative 3, but we want it in set builder notation. Set builder notation is this one right here. So it's just recognizing that. This is roster notation here. But we didn't want that. All right. So inequalities and set builder. Let's solve this inequality first. And 9 minus 4n is greater than 21. I'm going to change that subtraction to adding negative using the definition of subtraction. I'm going to take away 9 from both sides using the subtraction property of inequalities. And I get negative 4n is greater than 12. Then I'm going to divide both sides by negative 4. And I get n is less than, have to reverse the sign there because I divided by negative, negative 3. In set builder notation, the solutions are all numbers n such that n is less than negative 3. And I don't have to say all real numbers, that's implicit. That if I don't say they're whole numbers or natural numbers or integers, that I am using all real numbers. All right? Notice this, the empty set is written like that with just 2 empty brackets, and that is the set that contains no elements. It is a subset of every set. All right? So here we're finding subsets. What are all the subsets of the set? 1, 2, 3. And those subsets can have either 0 members, 1 member, 2 members, or 3 members. I'm going to list them separately. So all the sets that have 0 members, and we'll count the number of sets there are, and then we'll list those. So the number that have 0 members, there's 1 of those, and it looks like this. It's the empty set. For 1 member in the set, there are 3 of those, and that would be the number 1, the number 2, and the number 3. For 2 members, we have 3 of those, and those are 1 and 2, 1 and 3, and 2 and 3. And then 3 members in the set, there's 1 of those, and that is the whole set itself, 1, 2, and 3. So we can see that there are 8 subsets. Those of you in math counts might recognize these numbers right here from Pascal's triangle. And in fact, Pascal's triangle can be used to make sure you have all of the members of the sets. Okay, so here we go. We're going to list the subsets of the set P and of the set S. There is the empty set for set P. There is the sets with 1 letter, that would be either A or B, and then there's the original set which is A and B. And you can see here that there's 1 empty set, there's 2 with 1 letter each, and there's 1 original set. Again, those of you in math counts might recognize that as the second row in Pascal's triangle. The empty set. List all the subsets of set S. Again, the empty set is a set of every set, so we're going to include that one. there's 3 sets with 1 letter each. That would be A, B, and C. And there's 3 sets with 2 letters each. That's A and B, A and C, and B and C. And there's the original set, which is A, B, C. Notice if there's 1 empty set, there's 3 sets with 1 letter each, there's 3 sets with 2 letters each, and there's 1 set with 3 letters. So how many subsets does P have? P has 4 total subsets. How many subsets does S have? S has 8 total. Just as an aside here, if our original set had 4 elements in it, I'm going to guess, well, maybe I'll let you guess, just following this pattern 4, 8. How many subsets do you think a set would have if it had 4 elements? Talk to me about that in class. Anyway, all right. So, got it? Let A equal all numbers such that they are less than -3, and B be all numbers such that they're less than or equal to 0. Is A a subset of B? The blue arrow represents the graph of x is less than -3. The red arrow represents the graph of x is less than or equal to 0. Is the graph x is less than or equal to 3 part of the graph of x is less than or equal to 0? Yeah. Are the numbers from set A contained in set B? Yes. Is A a subset of B? Yes. Think about this. Is B a subset of A? All right. Finding the complement of a set. The universal set is everything you see in this rectangle. All vehicles. Set A is the set of vehicles that have 4 wheels. That's inside the circle. What is the complement of set A? So complement of set A, written A prime, and in roster form is everything that's not in A, and that would include the school bus and bicycle. That's the complement of A. Okay, go ahead and do problem 4. See if you can work it out, and I will put the answers up in a second. All right, use the months from the universal set at right. Write each month in the correct oval. Label each with year A or the complement of A. Exactly 31 days is set A, and not exactly 31 days is the complement of A. Months with 31 days are months like January, March, May, July, August, October, and December. There we go. And the ones that are not are February, April, June, right back here, June, September, and November. I have to stop the video here as I'm running out of time, but basically A prime includes February, or the complement of A, April, June, September, and November. I'll continue the video. There'll be a second part for this one.